So this is part 2 of our lecture that will go a little bit through the language C#, as a little tutorial, just to appreciate one object-oriented language. I'm sure that many of you are familiar with Java, but we want to give a fresh perspective on things. So we're going to look at C#. So C# is the main language on the .NET framework, which is what Microsoft considers to be the future of computing on the internet. It has many features that also exist in other frameworks. It is object-oriented. It has this feature of being compiled once and run everywhere, which also is available in Java. But importantly, it is geared towards service-oriented applications. So you might ask the question whether .NET is the Microsoft JVM. Well, it's hard to answer because there are significant differences. For instance, .NET is more component based, as opposed to JVM being a single machine concurrent virtual machine, single computer virtual machine. All right. So what's specific to .NET? .NET can be considered as a virtual machine. The language of the virtual machine is, or the underlying framework is this common language runtime. It is a framework that provides execution for a variety of environments, Microsoft environments, not only C# but also C and C++ and Visual Basic. There are several other higher level features like ASP.NET and WinForms for developing desktop applications. This CLR manages the execution of the code compiled for the .NET platform, and it has two important features. It's open. Well, it's open. It's not open source, but it's open. It's an open specification in the sense that Microsoft has made it public, and third parties can port it to non-Windows platforms. Microsoft does not provide the CLR for other platforms such as Linux, but it does provide enough information for others to implement it. And for instance, in Linux, there is a very good implementation of the CLR called Mono, which is supported by the former Novel software development company. Novel doesn't exist anymore, but it has been absorbed in some other company which continues to support Mono. And it is a common framework for executing a multitude of languages, not just C#, though C# was is the main one, right? So this entire package of the .NET and CLR and C# were developed together. So as I was saying, C# is the main language of .NET. Of all the other languages, not all of them fit so neatly in the .NET framework, right? Because .NET was designed specifically for C#. My pointer is not working. Okay. All Right, so in a way, C# can be considered a successor of C++. C++ was the main development language of Microsoft till the development of C#. C# also inspired Java. It inspired it in a way, in a strange way to a certain extent, right? Java was created by stripping off features of C++ that were considered harmful. C# was not so drastic in the sense that it kept very many of the features of C++ that Java decided not to keep, and also added a few that are supposed to enhance the ability to run programs on multiple platforms. So the design goals were the following: to be comfortable for C++ programmers, to fit cleanly in the .NET Common Language Runtime. Actually, they were designed together, so that has been achieved naturally. They wanted to simplify the C++ model, but without reducing the versatility of C++. Right, so you can see here, provide the right amount of flexibility. That was an important aspect. So C# in a way is a lot more flexible than Java, and supports component-centric development. Right, it works toward building or establishes service-oriented architectures as a main development architecture. What would be the differences? Let's say you are a C++ programmer, a proficient one for that matter, and how difficult would it be to learn C# from here? C# introduces a new notion of delegates, that is type-safe method pointers, right? So we don't have the typical pointers to functions that we used to have in C or C++, which can be assigned any value and can potentially lead to the execution of untrusted code. Instead, we have these delegates. They are pointers, but they are type safe. So whenever we manipulate such a pointer, we know for sure that it points to a method. So it is safe to call or execute a code that the pointer points to. They are used to implement event handling. You probably know by now that in event handling, we have to create functions that we should register with the services. In other ways, in other words, in the program at the when it starts executing, will not know what kind of events it's going to handle and what functions are going to handle that events. Those functions are registered as the program executes. So the manipulation of pointers to function is essential in that respect, right? And doing it safely also is very important, right? So this is one of the way to do it. Java also has a type safe of implementing event handlers. It doesn't manipulate pointers to functions, but rather it can use anonymous classes that implement given interfaces in an attempt to enforce the safety of the code that gets executed. It has some elements derived from Visual Basic and Java, but still C++ is the closest relative. An important change from C++ is that we do not require header files. Everything, all the code is written in line. We can import libraries, but we do not have to inline source files. The .NET framework will handle garbage collection. So garbage collection has become a mainstream feature in modern languages. Memory allocation is in no way manual anymore. C++ also had to a certain level of automation in memory management, but not to the extent that C# and Java have. And actually, if you look at all the modern languages, including Python, Ruby, all of them have garbage collection. Haskell or Camel, all of them have garbage collection. C and C++ are the older generation languages where memory management is still necessary. And one important feature that creates a lot of flexibility, but it comes as a trade-off. At a trade-off is that pointers can be still used in C#, not to the extent they were used in C++. So pointer arithmetic is not allowed, but pointers can still be used. But the code that uses pointers is required to be marked as unsafe. Right? Unsafe is a keyword that will be used on program regions that manipulate pointers as a way of making the programmer more conscious that it does perform something unsafe. And then a policy can be enforced through command line options that, for instance, programs should not have unsafe options. Right, so in a project, you may decide to have unsafe options or to completely do without them. So there are situations where performance gains are important, and manipulation of pointers will provide that. But we should limit the use of pointers only to those areas of the code. All right, so as with Java, in C# we have a base class, right, which is the class of objects. In Java, object is written capitalized. Here, object is written in small caps. There are many more specific differences. So, for instance, C# will have array-bound checks, which again tends to be a feature of most modern languages. So in that sense, it is also memory safe. There's a lot of similarity between C# statements and C++ statements, but there are several important differences. For instance, the switch statement has been changed so that fall-through behavior is disallowed, right? You are required to have a break at the end of every case for every case that is not empty. So then fall-through behavior is no longer possible. And also, no multiple class inheritance. So this is another feature that tends to be specific to most modern languages. C++ used to allow multiple class inheritance, creating a lot of ambiguity in the code, right? Or opening the door to a lot of ambiguity in the code. That has been recognized as harmful by many developers, and starting with Java, this feature is relegated from these languages. All right, there is also a new feature called properties, which allows getting and setting values of private variables through specific kinds of methods that are to a certain extent generated automatically. The scoping operator double colon has been changed, as it has been in Java, has been changed into the dot operator. All right, so in a way, the syntax is a bit more nimble. So let's look at a code example. This would be a skeleton of a C# application. We import libraries, right? The keyword is using, unlike in Java where the keyword would be import. And then we declare a class, and you will recognize probably the keyword public here. The class will be public. Inside we have a function, and again we have static functions and instance functions. So there needs to be a main function which has to have the modifiers public and static. The return value is void, and notice here that we can have a main without arguments. That is legal. We have example of comments, and they are exactly as in Java. So double slash will indicate a single line command, slash star will start a multi-line command which has to be ended by star slash. And this is the one-line printing procedure. It comes from the package called console, and the method name is called writeLine. It takes one argument and it executes, and you can type this program into Visual C# Express Edition, which is free. All right, and press F5, and this program will execute. You have to be careful in watching the output. So actually here you should have a console.read, so that you would read a character, and in doing that the window stays open so you can observe the output. Alright, if you don't have this, right, you can look for, and let's say you are on Linux, you can look for this package, the mono package, and the compiler will come as the executable MCS. C# files have the extension CS, and this will compile the program, will produce the executable hello world.exe. Even on Linux, right, the executable would be hello world.exe, and you can start the CLR framework with mono, so applying mono to hello world.exe will execute your program. If you are in a Windows environment and you have loaded the .NET framework, then the compiler will be called CSC. Of course, C# is a typed language, so we have types for variables and we have types for constants as well. More importantly, C# is not just a typed language, it's a type-safe language. It is not possible to create expressions and then change their type later, as it is possible in C, custom to a completely different type. So a variable would be declared as being of a particular type, and then from throughout the entire execution, that variable will hold values of that specific type. It cannot be changed. We can place in a variable either value types or reference types, as we would do in Java, just that it is not the case that every object is a reference necessarily. And we have a number of base types, exactly as in Java, and in general we can create objects, but we are not constrained to see every object through its reference. We can see it as a value. We can also have pointers to these to a value of some type, but remember, pointers are unsafe. So a variable of value of some type contains only an object with the value, right? So the object has the value. The object is not a reference to the value, or not necessarily, right? But we can create variables of reference to a type, right? So actually, this is the type. Having a reference is a type. We can create, right, a type that is a reference to another type, and then we can create a variable of that reference type. So then that variable will hold a reference to an object. And multiple variables may contain references to the same object, leading to the problem of aliasing, which is a potential source of bugs in many languages, and some languages try to to relegate this, but the potential efficiency benefits that we get from aliasing in general outweigh the costs, the dangers that may result from that. All right, of course, we can declare our own types as enumerations or structures. There's a table of predefined value types. We have, unlike in Java, we have values of all sizes. So from 1 byte up to 12 bytes, if you look here. And all of them have both signed and unsigned versions, again, unlike in Java. So C# is a lot more versatile. All right, so let's look at a few examples of value types. Of course, the easiest way is to declare an integer variable where integer is a base type. It has the syntax that you would recognize from many other languages. C, C++, Java, all of them would have this syntax. Int x is assigned 10. So obviously, x is a variable whose initial value is 10. We also can declare objects. And remember, the base class for objects is this keyword object in small caps. And we can declare, perform a declaration like this: object x is assigned new object. And again, this looks like very similar to Java. And then let's say that inside x, we have declared some field called myValue, then which might be an integer. We can assign that to 10. Strings come in the natural way, just that in C# there's less capitalization. All right, and remember that Java had these dual types called box types. So every base type will have a box type, an equivalent box type. So for instance, integer, int, right, integer, which is a base type, will have as its dual, as its boxed dual, the class integer capitalized. The class double, the base type double would have as its boxed dual the class double. And since Java 1.5, there are implicit conversions that can happen between these types, and these conversions are called boxing and unboxing. So for instance, I can pass as an argument a box type which is automatically unboxed. If I have a method that takes a int as an argument, and then I have an integer x, right? Then I can pass this x into I as an argument, and x will be automatically unboxed. X will be converted from a box type, from the class integer to the base type integer on the fly. Also, it is possible to assign values to box type. So I can say integer x and then assign the value 3 here, and 3 will be automatically converted into a box type and assigned to x. It so happens, actually, I was going through a book that is describing subtleties of the Java language, and the author there was actually not very happy at about this automatic conversion, and was showing quite a few cases where the expressions written with that were mixing boxed and unboxed types were producing results that were not those that you might have expected intuitively from those expressions. So it's actually not very clear whether this was a good addition to Java. Now, this boxing and unboxing happens in C# as well. It's an important feature because you always want to, the base types are the types that can be represented inside a processor. So operations with these types are very efficient. On the other hand, Box types are objects, so they respect the object hierarchy. They can be extended by other classes. New operations can be added to them, right? So they're a lot more flexible in a way. Obviously, they will not be as efficient as the base types, but they allow for more elegant programming. So then we need these two kinds of values to coexist, and we need conversions to be possible between these types. And often, if, let's say, the conversions are not implicit, we might need to go through a lot of trouble to have them to allow them to work. So therefore, implicit conversions can be a good thing when used carefully. So now let's say we do have two objects. One is boxed and the other one is unboxed. So this is the unboxed one. This would be the boxed one, and see how we can test the relationship between them. Right? We can say if box is int, so box is the box type, and it does contain an integer, right? So we can check whether that happens and perform some action based on that. Pointers have a syntax similar to C and C++, right? The dereference, the pointer dereference operator is star, as in C. The operator that captures that takes the address of a storage location, of a memory address, of a memory location, is the same, ampersand. And if you look at this piece of code, which is a valid piece of C# code, you might very well believe that this is C or C++, right? So the syntax is completely identical. But remember, whenever we do that, we have to place this in a block that is marked as unsafe, right? So this is part of a bigger program, and at the beginning of the block, we would need to have unsafe, right? So we write unsafe, and open a brace and close the brace, and we can use pointers. Now, pointers, another problem with pointers is that they interfere with garbage collection. All right, so to address that problem, one can declare a pointer within a fixed expression. Right, so this is the declaration that we add to some variables, and whenever we have unsafe code, that is automatically fixed. And if we have value types declared within unsafe code, that will generate compile time errors, right? Because that will interfere with garbage collection. We want garbage collection to proceed smoothly. So there's a constraint that in general is not overly restrictive for regular programs. So pointers can only be used with value types, and it can also be used with arrays, right? So that's one of the exceptions to the value types rule, right? So this is an example. We have an array here, and we can take a pointer to this array. However, we won't be able to write star b plus 1 is assigned 6, let's say, as we would do in C. Pointer arithmetic is not allowed. So that this brings us to the topic of arrays. This would be a typical declaration of an array. Again, is very similar to Java, and it has the same semantics. It declares an array I that is initialized to an array of 100 elements. A new an element of novelty in C# is two-dimensional arrays, the kind that are guaranteed to be rectangular. Um, right, so they would be declared in this way. We would have two dimensions, and the dimensions are separated by commas, and such an array has to be initialized with rows of the same length. So notice here that this is the initialization of the first row, this is the initialization of the second row. They must have the same length. Java or C type of arrays, which would be declared like this, right, are called jagged arrays. These arrays are not forced to have, are not constrained to have equal-sized columns. And in fact, this represents an array of arrays, right? So it's an array of arrays. Each array, each individual array inside the bigger array is an independent array, so it has its own size. So the rows of the jagged array are not constrained to be of the same size. And you can see it here. This would be a typical initialization. Notice the fact that for every row, we emphasize the fact that every row is a different array, and obviously it can be of a different size. Enumerations are means of creating symbolic constants, especially that are distinct from each other. This can be achieved in a variety of ways, but having a specific type called enumeration is the most flexible and efficient way to do it, right? It frees the programmer of actually picking the constant values for those symbolic constants. These are examples, right? They can be declared of any type or of no type at all. We're just calling this one days, and we're letting the compiler choose the size, whether they should be 16 bits or 32 bits or 64 bits. In other cases, we enforce the size. So we want these two symbolic constants, a and b, to be of size byte, and of course a and b should be distinct. Most compilers in most languages, there will be a fixed rule of assigning values to these constants, usually starting from the 0 of that type. So if we have this byte here, in principle, the value of a would be 0, the value of b would be 1, and this can be altered by the programmer by indicating its own values, though that in general is not recommended. It is not good software engineering practice to set the values manually. It's much more flexible to allow the compiler to choose. So this is a little program that uses enumerations. We declare an enumeration type which contains days, and we want this type to be of size byte, so 8 bits. And we have a main program where we declare an array, and so that's a very interesting thing, right? From an enumeration, we can get an array of all its values in this way. And then we can write a for each loop where this is an iterator, exactly as in Java, and this is a variable, and this is the type of that variable. And for each value returned by the iterator, right, this variable will take that value and then execute the body of the for statement, right, and this will lead to a printout of all the days in the enumeration, of all the elements in the enumeration. This write line performs a formatted write, and notice the use of these fields enclosed in braces, right? This will stand for the first argument after the string, after the formatting string. So this is the formatting string, and we're going to have argument 0 here, argument 1. And notice that we're using the arguments in reverse order. This will be argument 1, and this will be argument 0. And notice how we do here, what we do here, we enforce that the window stays open so we can see the out. This would be the output. All right. So notice the fact that we have reversed the usage of the arguments. All right. And all right, so there's an implicit cost here. That's what we want to emphasize on this slide, that we are applying this method, console.writeLine, and it takes a string, but actually because of the occurrence of the formatting specifiers in the string, in fact, the system will automatically apply another method, string.format, to that string to obtain a full string that can be printed out. All right, so to explain further what happens in there, right, this will be the expression produced by string format, right? So this string format takes in a string and converts it to another string, and the string starts here, right? So this will be the string from starting here and ending here. So notice how the two extra arguments to writeLine have been placed, right? Not in the order in which they appear in the function call. Obviously, as this case with Java, we have a very rich type hierarchy that leads to a very powerful API that can perform all sorts of conversions between a variety of types and all sorts of formatting for strings that need to be printed on the screen. And this is just a glimpse of what is available. As in C#, we can redefine operators to operate on new types. We can overload an operator, right? This was not possible in Java. Overloading of operators leads to to programs looking a lot more elegant. But nevertheless, this comes with restrictions, right? So we can only overload the existing operators. We cannot add new operators. We have to keep their current precedence. All right, and of course, we can only define these operators for new types. We cannot predefine them for existing types, for types that were predefined by the framework. Nevertheless, this is a very flexible feature. Allows for programs, in many cases, to look a lot more elegant. For instance, think of the fact that we might declare a complex type, right? And then we want for our complex variables to have addition, subtraction, multiplication, division, and we overload the current the plus and minus and star and slash operators to perform these operations between complex numbers. Then our programs will look a lot more elegant, right? Resembling their algebraic expressions that we know from theory. For jump and selection statements, they are pretty much as we know them. So we have a break, we have a continue to jump out of while and for loops. We have go-to statements, which have been relegated from Java, but C# decided to keep them. We have the if-else statements, which again are exactly as we know them, and switch statements are pretty much the same as well. Just remember that their fall-through is not allowed anymore. Looping statements again are the usual ones. So we have while, we have do while, we have for loops, And we have 4 each loops, which again become a staple of modern languages. Pretty much all languages have them now. So Java has a for loop for each kind of loop. Python has it. Uh, uh, yeah, many languages. Ruby has it as well. Have this kind of construct. Um, the syntax is like this. We can declare a variable right inside the for loop, and then that variable will take every value that is returned by the collection A and will execute the body of the for loop for that value. Now, the important part is, since C# is an object-oriented language, the important construct that we have in such a language is classes. However, classes are, to a certain extent, templates, blueprints for an object, and objects are called instances. As with most object-oriented languages, we have well, no, that's actually not true, right? So since Java 1.5, we have templates in there, but C# has a very elegant way of mixing object definitions with parameterized code, right? Providing a means of parametric polymorphism, which is in general much stronger than the one in Java. Java could not come up with a full-fledged polymorphic system because of backward compatibility. C# did not have that problem. Actually, C#, Microsoft was the leader in this area, and only when C# had this feature and Java saw a serious competition from C#, the Java maintainers decided to add, to the greatest extent possible, a similar feature to Java. However, due to backward compatibility issues, that feature could not be expanded to its full power. All right. So then, besides, so we in a class we can have parametric types, and then inside we can define other types. This is possible in Java as well in the form of inner classes. But here the concept is known as containment or aggregation, right? It is part of encapsulation. We don't want to expose to the outer world things that the outer world should not be concerned with. So we try to hide as much as many things as possible inside a class. As with Java, C# can extend a single base class or implement any number of interfaces, right? So this appears to be another mainstream feature of object-oriented languages in modern times. One feature that C# decided to take from C++, and Java didn't, is namespaces. Namespaces are a very useful feature for avoiding name clashes and avoiding the pollution of the global namespace with names that would be otherwise used in a very restricted manner. One thing is, with the keyword using can import a library or can import a namespace, can import a set of declarations that would be made available for a limited region of the code. Namespace can be nested, as you can see here. All right. Class declarations are exactly as you expect them. So public class and name of the class, exactly as in Java. But a declaration can have attributes, right? Can have a number of attributes that can be placed in front of the declaration, which would be user-defined metadata about the class, which can be brought out at runtime. Java has a similar concept called annotations, right? So in Java, you can write at and you can put, for instance, override or one of many annotations, right? Indicating, for instance, in this case, that the function you're about to write or the method you're about to write overrides a method in the superclass. So this also becomes a staple of modern object-oriented languages. We can have user-defined attributes, as in Java we can have user-defined annotations, and this allows the third parties to write their own program processing tools that will take advantage of these annotations and provide extra checks for the program, so as to enforce the fact that the program should comply with certain policies, for instance. Methods, again, have syntax that is very similar to Java. So, in principle, there's a return type. As in Java, there's a method name, there's a list of formal arguments, and then there's a definition in curly braces. But, you know, as with most other languages, we can add information to a declaration in the form of attributes and method modifiers. So method modifiers would be things like public or private or static, and attributes are attributes that can possibly be user-defined, such as override. C# did a much better job at implementing polymorphism as compared to Java. There are two important ways of performing polymorphism. We discussed them, right? So hiding and overriding, and combined with parametric types, right? We also have parametric polymorphism. So when we override, in order to override, we need to explain exactly in what way do we want to override. So we have to use either of these three keywords. So if we declare a function as new, it will behave as the previous definition did not exist at all. If we implement it as virtual, it will have the standard behavior of methods in object-oriented programming, meaning that the method of the superclass is still possible and still callable. We can call super.method, right, when the overriding method is virtual. Or we can completely override a method, meaning that in this class the super is not available, but in the superclass, when the superclass is used as a standalone object, the old method takes precedence. Right, so in the end, these keywords will control that whenever we use a method name, which method should be invoked. All right, let's look at another code example. This is a stack, and it's a stack of integers, right? And notice that we're declaring it private, right? We have a few other private data members that control the stack behavior. There's a constructor. Again, so far you could think that you're in Java, just with the difference that this string is not capitalized. We have public push, public pop, right? Two methods that perform the standard stack operations, and we also have two accessors, right? The top and empty, and this will be a stack class. Very, very simple, very, very straightforward. This would be an example of usage of that stack. So we'll have a main procedure, and we create a stack, right? And we perform some operations, right? And then we inspect the stack to check that the operations have been performed according to expectations, and perform some more operations, print again, take another peek at the stack, and then some more operations. And this one should try to pop from an empty stack and produce an error message, and in this way we check that the behavior is consistent. All right, let's take a look at delegates. Delegates are reference types which allow indirect calls to methods. We can give to another method, right, a method that would handle an event. If you have some experience in GUI programming and graphic user interfaces, you would know that every widget in general wants or needs listeners. Listeners are methods that would be invoked when certain events occur, and these listeners would not be known at compile time. They have to be provided by the user at runtime, right? So they would be provided usually in the form of, if we program in Java, in the form of an anonymous class that contains a specified method. Here we want to use, the concept that we use is delegates. And they're functionally very similar to C++'s function pointers, not so much to Java's anonymous classes, right? So remember, they're reference types. They're not really pointers. And they're type safe, meaning that whenever you hold such an object, it is guaranteed to point to a valid method. You cannot assign it to change to point it to something else unless it's another valid method, and then it is always safe to invoke. This is an example. Right, we have a we have an object of type ticker. Sorry. We have an object of type ticker, which needs an event handler that should be invoked on every so many milliseconds, right? So this is the ticker. This is the method whose that we want to delegate, that we want to use as a delegate, right? It is inside this class, and it can access this private integer. And this is the example, right? We have a class called delegate example, and this is the main function. So the first thing that we do is we create a delegate, right? And we take this method, right? Notice how we use it. We actually use that name without parameters. So it's pretty much like in C. It's the address of the function, right? So this evaluates the address of the function in C#, and we create an event handler with this delegate, right? This event handler can be set, can be sent to a timer, right? And set to be invoked every 500 milliseconds, right? So this is now a delegate. It's a wrapper that contains an address of a method, and it is type safe. So what we do now is we let this timer run, right? We let this timer run, and that timer will be invoked on every tick by a signal handler that is connected to the system clock, and the main thread will sleep. All right, but nevertheless, throughout the sleep, it's a sleep of 10 seconds. Throughout the sleeping of the main thread, this method right here, the tick method, will be invoked 10 times every 500 milliseconds. So this counter will be increased to 10. Okay. So this is what delegates are, a type-safe way of handling pointers to functions. As far as input-output is concerned, this works in a manner, again, similar to Java, right? So we have libraries for input-output, and these input-output is based on readers of streams, right? We regard the input sources and output sources as streams. There will be a standard input stream, a standard output stream. And if we have an input stream, of course, we need to create a stream reader that can, from where we can fetch more data available on the stream. In general, a stream can be created just from a file name. So if we provide a file name as the first argument to the program, then this will become a file, the equivalent of a file handler, right, in C. So we have a stream reader from which we can read text line by line. So we create a buffer that can hold the line of text. And what we want to do is copy the input file into an output file. So we ask the user for a output file name. We create similarly we create a stream writer, and then we just perform a line-by-line copying, right? We read a line. If the line is valid, we write the line. And actually, we write the line in two places. We write it on the screen as well as into the file, right? So we are going to have on the screen a copy of every line so that we can see the progress of the program. At the end, obviously, we have to close the two streams. Notice, so another element of novelty here is the way, well, it's actually not an element of novelty for us who haven't seen it before, right? So this is how arguments are accessed. Arguments to the entire program, command line arguments, are accessed from a program, and this is completely similar to Java. We have an array of strings, and we give it a name here, and then the space-separated arguments to the program would be available as strings inside the array. Exceptions, since we just talked about them. All right, so let's go quickly through them. They're very similar to Java again, right? So we have a try catch block. So we have a try, right? We have a catch block here. This is the catch block. Never quite understood how text selection works in PDF document. All right, and this is a method that we're invoking. This is a method that we're invoking, and it is expected to throw an exception. Okay, and this is the exception handler, right? Which is very simple. We just print we got an exception. We have the finally keyword. Finally is a section of the exception handling that enforces that the code inside will be executed under any circumstances. So irrespective of whether we throw or not throw an exception, that code is executed. And it's always useful to have this section of the code because we may want to close files or unlock locks to avoid deadlock in concurrent programming. In general, do clean up code that needs to be done in order for the program to close up correctly. This is how we throw an exception, right? This is the function that is supposed to throw an exception. It simply throws one. And again, it's very similar to Java, right? We have this constructor. We create a new object of type exception. We just throw it. The exception constructor will accept a variety of parameters that can provide more information about the condition that caused the exception. But we are keeping things simple on this slide. We just throw the simplest exception that we have available. And this concludes our tutorial. We will have a few examples in the tutorial class in 1 week's time on C#, so hopefully that will help you become more familiar.